When troubleshooting BGP peering down issues, the first thing that we are going to look at is the configuration. It is very important, even if you are thinking that your configuration is perfect and you have configured it correctly, it doesn't harm to look at twice. While looking at the configurations, you might notice your peerings within your configuration section are either for iBGP peers or they are for eBGP peers. For iBGP peers, ensure both your local AS number and your remote AS number are same. For your eBGP peers, ensure that you follow the documentation that you have received from your service provider or your remote peering AS number company or organization. They have given you an AS number. Ensure that AS numbers match for the remote peers on eBGP connections, and ensure that you provide the right AS number for your AS to the remote ISP or the organization. The second thing that you need to look for is the local and remote peering IP. Sometimes what happens is we are trying to establish a peering between the loopback IPs, and mistakenly, maybe due to typo or maybe due to human error or documentation issues, we actually configured the connection based on your physical IP. In those scenarios, what will happen is if the remote ICE side is configured for peering with the loopback and this side is your side is configured for peering with your interface IP, then the connection might not get established. The third important thing to look for is your eBGP multi-hop. For eBGP connections, usually your peering will be on the directly connected interface. But if they are not, if the device or the remote peering device or IP is multiple hops away, in those scenarios, you actually need to ensure you're configuring the correct hop count. By default, if you don't configure any hop count number, it takes the value of 255. So remember, as a best practice, it is good to configure the exact hop count. Authentication. This is optional. You don't really have to configure authentication for all your iBGP or eBGP peerings. But these provide security for your eBGP connections, and a malicious device cannot try to establish a connection or iBGP connection or eBGP connection with your device or even send malicious packets. So in that scenario, it is good to have authentication enabled. So when you are doing configurations, ensure you have verified all these 4 areas. Now let's look at some of the configurations in this environment. We have 3 routers, R1, R2, and R3. R1 and R2 are running iBGP connection, whereas R2 and R3 are running eBGP connection. They have their loopback addresses configured in the same way. For R1, it is 192.168.1.1. R2 is having 192.168.2.2. R3 is having 192.168.3.3. Now let's look at the eBGP connection configuration. If you look at it, the configuration here says neighbor 10.1.23.1 activate, and the remote side says 10.1.23.2. This is what is happening when you're configuring neighborship on the physical IP. Obviously, you first need to configure the remote AS number or the connected or the source interface information, but otherwise, you just need to go under the address family and configure activate. If you are peering over the loopback interfaces, that's where the fun comes in. You need to configure the source interface. So it will take update source loopback 0 means you're using your loopback 0 IP for peering or establishing a BGP connection with the remote device. And similar on the remote device, it says neighbor 192.168.2.2 update source loopback 0. That means it is trying to use its loopback 0 interface to establish a connection with 192.168.2.2. Then comes the third configuration, which is eBGP multi-hop. Now remember, this is a directly connected interface. There are no different hops or multiple hops between these 2 devices. But even then, while you're peering with the loopback interface IP, you are using the configuration eBGP multi-hop, and the number is 2. The thing is, by default, when you're establishing eBGP connection, the router uses connected interface check. This mechanism checks that it is establishing a connection on the directly connected interface. If you actually disable or if you're not using your directly connected interface, then you might have to specify eBGP multi-hop. But if you disable the check, then you might not even require to configure eBGP multi-hop. You can just say neighbor 192.168.3.3 disable connected check, and this will take care of specifying eBGP multi-hop. And finally, you go into the address family and configure activate. Let's get into the lab side of it. Looking at the configuration, router 3 is running Nexus OS. It has a different way of showing the configuration. So you run the command show run BGP and you can see the configuration. Notice that the first line says feature BGP. If you do not enable this configuration, the BGP related CLI will not even be enabled. You cannot even run any BGP related commands. So this is the first and the foremost thing that you're required to do under Nexus OS. You enable the feature. The second thing is you can see here the configuration says neighbor 10.1.23.2, remote AS 100, address family IPv4 unicast. And this is IOS XR. So you run the command show run router BGP. And you can see here neighbor 10.1.23.2, 23.3, and remote AS 200, address family IPv4 unicast. So in XR, you need to do things a bit differently, similar to Nexus OS. So first, you configure the router BGP with the AS number. You assign a BGP router ID, and then you enable the address family. So if you notice, the third line of the configuration says address family IPv4 unicast. This means that your address family IPv4 is enabled. And now when you configure a neighbor and you put the command address family IPv4 unicast under that neighbor IP, that means you are configuring that neighbor for that particular address family. If you have a different address family as well, you can put multiple address families under the same neighbor command. And this will take care of enabling the neighbor for different address families. When you have configured the neighbor command and address family, this should take care of the configuration. If you look at the other piece of the configuration, it's peering with 192.168.1.1 with remote AS 100 and update source loopback 0. Means it's trying to establish a connection with loopback 0 IP. And address family IPv4 unicast, you enable the address family, and finally configure next hop self. Well, next hop self is usually required when you have eBGP to iBGP connection and you want to tell your iBGP peers that in order to reach any remote destination IP, I am the next hop. It's not used for actually establishing a BGP relationship.